Good morning, students. Today we will be discussing about symmetric compound pendulum. This is our laboratory experiment. We'll be doing the symmetric compound pendulum experiment virtually using Amrita Virtual Lab facility. Before we use the Amrita Virtual Facility, let us discuss about the aim, apparatus, principle, procedure, and how to find the acceleration due to gravity using symmetric compound pendulum. So just like we know, a pendulum is mainly used to find the acceleration due to gravity at a place. So we have here a compound pendulum. A compound pendulum mainly consists of a uniform bar 1 meter long having equidistant hole drilled in its length, and this pendulum will be suspended on a knife edge. So the center of suspension is on near to the knife edge. Okay, so let's discuss the aim. The aim of our experiment is to find the acceleration due to gravity at a place. The apparatus we need is compound pendulum, a stopwatch, and a pointer. Now, what about the procedure? Okay, before coming to the procedure, let's see how a compound pendulum looks like. Just like previously we have said, compound pendulum is a bar compound pendulum is 1 meter long. So this length is 1 meter. It is having some holes equidistant from each other. Say, let's consider these holes are 5 centimeter apart. Centimeter apart, having a length of 1 meter. Okay, and now what we are going to do is we will be keeping a pointer. There is a knife edge, and we will be suspending our pendulum on the knife edge, and this knife edge will be here. It will be fixed. Okay, so we will be keeping the knife edge here. We will be placing the symmetric compound pendulum here. Then after that one we will be using the other hole. The distance we will be changing the distance and oscillating. Okay, so let's see how the principle is. So as we know, if L is the length of the pendulum, equivalent simple pendulum, and T is the time period, then we know T is equal to 2 pi root L by G, and from this equation we will be getting acceleration due to gravity. G is equal to 4 pi square L by T square, where G is the acceleration due to gravity at a place, L is the length of equivalent simple compound pendulum, and T is the time period of the simple compound pendulum. Okay, now let's come to the procedure. Here, what we will do, the pendulum is suspended by passing the knife edge through the first hole near the end, just like we have shown in the previous slide. The pendulum will be suspended in the first head. A vertical pointer will be arranged in front of the pendulum to mark its equilibrium position. To understand the equilibrium position, we will be keeping a pointer here. So this is the equilibrium position, and then we will be oscillating this pendulum. Okay, now so now the pendulum is made to oscillate in small amplitude vertical to the plane, and time for 20 oscillation is determined. This experiment or this procedure is repeated, and the average time is noted, and from the average time we will be calculating the time period. Time period will be calculated using t, the equation t is equal to time by number of oscillation. Here the number of oscillation is 20, so from dividing the time by 20 we will be getting the time period. So to determine the length of equivalent pendulum, what we do is we will be drawing a graph, plotting a graph between the time period and the distance, and we will be getting two curves just like the figure indicates. The line, you can see there is something called as M and N. So this M and N, the line perpendicular to the x-axis is drawn with N corresponding to the center of gravity. So how can we get the center of gravity? The center of gravity, we will be taking the whole uh, compound pendulum, and we will be balancing this compound pendulum on a knife edge. On a knife edge, once we balance, we will be able to get the center of gravity, and then we will be drawing a line uh, corresponding to the center of gravity. Say this Mn, let this Mn line, which is perpendicular to the x-axis, shows the center of gravity. Now we will be drawing a line which will be perpendicular to the y-axis from the time period t1, and this line will be cutting the curves in A points at A, B, C and D. So to get the length of the equivalent pendulum, we will be taking L as length as AC plus BD by 2. Now the second thing which we need to calculate, the second quantity which we need to calculate is the radius of gyration. The radius of gyration can be calculated using two methods. One is we can directly calculate from this line that is cutting the uh, curves. That equation will be k is equal to root of AG. AG will be for this one. We will be taking AG and GC. Okay. So from that one also we will be able to get k. Other than that one, if E and F are the two minimum points of this curves, then corresponding E and F, the distance between the E and F will give you the 2k, and k will be EF by 2. Obviously from this k we will be able to understand, we will be able to calculate the moment of inertia. The moment of inertia can be calculated by the equation mk square, where m is the mass of the pendulum and k is the radius of gyration. So this is the whole principle and procedure related to our symmetric compound pendulum. Now let's see how to do the experiment using virtual labs. So I have already logged in to the Amrita virtual labs, and I have selected the physical science. And physical science, there is another subhead, advanced mechanics virtual lab. In advanced mechanics virtual lab you will be able to find symmetric compound pendulum. And just like we have already discussed, there is a long bar pendulum, compound bar pendulum, and it is having holes drilled in equidistant. Say let's consider this a distance as 5 centimeter from the point A, and now what we are going to do is we are going to oscillate the pendulum. Just like this, we will be oscillating in our lap. So the pendulum is suspended on the knife edge, and then we are oscillating this pendulum. And here you can see the stopwatch. Now what we will be doing is once the uh, pendulum comes to any extreme points, we will be taking, okay, so let's keep the pointer here, and we will be taking the, we'll be taking, we'll be starting our stopwatch. Okay, so let's start from now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we we got the time for 20 oscillation. We will be entering that quantity here. So the distance from knife edge, let's consider it to be 5. We took the number of oscillation as 20, and we got the time for 20 oscillation as 30.9. So let's consider this one as 31. Now again repeat the same experiment, that is for the 5 centimeter we will be again oscillating the pendulum, resetting the stopwatch, we will be again starting, and let's consider that also to be 31, the time be 31. So we took the mean and we got the time period as 1.55, and we need to do the same experiment with the change in position, changing in the distance, and we'll be completing the whole experiment using by repeating the experiment with different distance and with different time for oscillations, for n oscillations. Okay, so you can add the quantities here for next uh, observation, say 10, 15, like that you can do. And to find the acceleration due to gravity, we need to find the length of equivalent simple pendulum. And just like we previously showed the graph that the line cuts in 2 points, let's consider that points to be 60 and 60, AC and BD to be 60, and time period as 1.55. So we will be getting almost 9.8, which is the almost equal to our acceleration due to gravity, which is 9.8. So I hope you all understood the uh, experiment, symmetric compound pendulum. Thank you.